everybody. Today we'll be factoring polynomials. I'm going to do an example without talking, and then I will explain my process. Okay, so we're going to go through that step by step. Here is our original polynomial that we're starting with. And every time that we are trying to solve a polynomial that looks like this, now here's the features you're looking for. There isn't a number here. That's called a coefficient. The number that's at the very front, in front of this x squared here, is called a leading coefficient. So because of that, we can use this system that I'm about to show you. The leading coefficient, there's a lot of different ways to solve that. The main one, I believe, is completing the square. So there isn't one of those, and this is a like the largest of the x's in here is squared, and there's only 3 terms. X is the only variable, so this is the simplest form of a polynomial that you might need to factor. So in this one, I have named the numbers. So this one, there isn't a number here. We can just say, if we want, that it's 1, because 1 times x squared is the same as x squared. So I've named this one A, this one B, and this one C. That helps me remember which one is which and helps me explain it. So B and C are the critical numbers here. B equals 16, C equals 60. Now, I'm going to push this to the side for a moment. Oh, we don't need any black paper. That's hard to write on. Okay, we're going to come back to that for a second. If I have x plus d and x plus e, an example of that might be x plus 2 and x plus 5. We can multiply these out and know what happens. So x times x is x squared. X times e is ex. D times x is dx. And d times e is de. So let's we can simplify that down a little bit. X squared plus d plus e x, because we're putting those together, plus de. So let's say that we can apply that here. I can multiply it out for you in a second. Actually, let's multiply it out first, and then I'll show you how we can apply this. So x times x is x squared. X times 5 is 5x. 2 times x is 2x. And 2 times 5 is 10. We can put those together. X squared plus 7x plus 10. Now let's see if we can apply this. We're saying that if these two are the same, then D equals 2 and E equals 5. So if this equals this, then x squared would be our first term. D plus E, so 2 plus 5 is 7x. And DE is our last term, so 2 times 5 is 10. So you can see that these are the same. Therefore, if x plus D times x plus E equals x squared plus D plus E x plus DE, then we can come back around to this. So we see here that what I'm calling B actually equals D plus E, which are these two terms. X, X. So this one's D, a little D up here, and this one's E. So B equals 16, which also equals D plus E. C equals 60, which also equals D times E. So I want to find something that multiplies to 60 and adds to 16. So these are all the numbers that multiply to 60 in the positive direction. We could make them all negative, so -1 times -60 also equals 60. But I choose to keep them in the positive direction unless I have a reason not to. And since all the numbers we're currently working with are positive, we'll start there. So then after writing all of these pairs out, I found the one that adds to 16, which is 6 times 10. So 6 times 10 is 60, and 6 plus 10 is 16. So our two numbers here are 6 and 10, like I've put here. Then I can just plug those in, just like in this equation here. 6 and 10. All right. That may not have been the best way to explain it, but it is a way, and I hope it helped. Thank you.